Hello and welcome to my YouTube channel ChemWis. In this video we are going to discuss chloro pattern in mass spectrometry. When a molecule has one or more chlorine atom in it, mass spectrum of the molecule displays a specific pattern of M, M plus 2, M plus 4, M plus 6, etc. based on which we can easily find the number of chlorine atom in the molecule. There are two methods, detailed method and shortcut method. We will discuss both the methods, but first let's discuss detailed method. Let's have a case 1 in which the molecule has one chlorine atom. Chlorine has two isotopes, Cl35 and Cl37. If we talk about their natural abundance, Cl35 is 75% and Cl37 is 25%. Or we can say that the relative abundance of Cl35 and Cl37 is 3:1. Suppose we have a molecule RCl with one chlorine atom in it. If the mass of R group is W, then there will be two types of molecules, RCl35 with molar mass W plus 35 and RCl37 with the molar mass W plus 37. The peak in mass spectrum corresponding to W plus 35 is labeled as M, while that of W plus 37 as M plus 2 because the latter peak has 2 units higher mass. Their natural abundance will be 75% and 25%, same as the natural abundance of chlorine isotopes. In other words, their relative abundance will be 3:1. Therefore, the intensity ratio of M and M plus 2 peaks will be 3:1. Thus, if mass spectrum of a molecule shows M and M plus 2 peaks with the intensity ratio of 3:1, then the molecule has one chlorine atom. For example, chlorobenzene. Since there are two isotopes of chlorine, so in a sample of chlorobenzene, there will be two types of molecules, one with Cl35 and other with Cl37. We know that the molar mass of phenyl residue is 77. So, the molar mass of chlorobenzene with Cl35 will be 77 plus 35 is equal to 112, and that of chlorobenzene with Cl37 will be 77 plus 37 is equal to 114. In mass spectrum, there will be two molecular ion peaks, one with M by Z 112 and other with M by Z 114. So, the peak with M by Z 112 will be M, and that with M by Z 114 will be M plus 2 peak. The intensity ratio of M to M plus 2 will be equal to relative abundance of chlorine isotopes, that is 3:1. This is the mass spectrum of chlorobenzene. These two peaks M and these are two peaks M and M plus 2 with M by Z 112 and 114 with the intensity ratio of 3:1. Case 2 in which a molecule has two chlorine atoms. Let's represent the molecule as RCl2. A molecule may have both the Cl35. It may have one Cl35 and one Cl37. There are two possible combinations: molecule with Cl35 and Cl37 and molecule with Cl37 and Cl35. Third type of molecules are the molecule with both Cl37 atoms. The peaks with mass corresponding to these molecules respectively are m, m plus 2 and m plus 4. Since the relative abundance of Cl35 is 3 and that of Cl37 is 1, so the relative abundance of m will be 3 into 3 is equal to 9. Relative abundance of m plus 2 peak will be 3 into 1 plus 1 into 3 is equal to 6. And that of m plus 4 will be 1 into 1 is equal to 1. So the intensity ratio of m plus 2 and m plus 4 peaks will be 9:6:1. Thus, if mass spectrum of a molecule has m plus 2 and m plus 4 peaks with the intensity ratio of 9:6:1, then it has 2 chlorine atoms in it. For example, 1,4-dichlorobenzene. There will be 3 molecular ion peaks, m plus 2 and m plus 4. Since the mass of phenylene residue shown in blue is 76, so mass of m peak will be 76 plus 35 plus 35 is equal to 146. Mass of m plus 2 peak will be 76 plus 37 plus 35 is equal to 148, and mass of m plus 4 peak will be 76 plus 37 plus 37 is equal to 150. The intensity ratio of m plus 2 and m plus 4 peaks will be 9:6:1. This is the mass spectrum of 1,4-dichlorobenzene. These are m plus 2 and m plus 4 peaks with m by z 146, 148 and 150 with the intensity ratio of 9:6:1. Let's study case 3 in which a molecule has 3 chlorine atoms. We can represent the molecule like as: based on isotopic distribution of chlorine atoms, there are 4 possible sets of molecules. Molecule with 3 Cl35 isotopes, molecules with 1 Cl37 and 2 Cl35. In this set, there are 3 possible combinations of Cl isotopes: 37, 35, 35, 35, 37, 35 and 35, 35, 37. Third set has the molecules with 2 Cl37 and 1 Cl35. So in this set too, there will be 3 possible combinations: 37, 37, 35, 35, 37, 37 and 37, 35, 37. And the fourth set will be molecules with 3 Cl37. These sets will correspond to m plus 2, m plus 4 and m plus 6 masses. Since relative abundance of Cl35 is 3 and that of Cl37 is 1, So the probability of finding these combinations will be 3 into 3 into 3 is equal to 27. 1 into 3 into 3 is equal to 9. 3 into 1 into 3 is equal to 9. 3 into 3 into 1 is equal to 9. 1 into 1 into 3 is equal to 3. 3 into 1 into 1 is equal to 3. 1 into 3 into 1 is equal to 3. And 1 into 1 into 1 is equal to 1. Therefore, the relative abundance of M is equal to 27. M plus 2, 9, plus 9 plus 9 is equal to 27. M plus 4 is equal to 3 plus 3 plus 3 is equal to 9. And that of M plus 6 is equal to 1. Thus, the intensity ratio of M, M plus 2, M plus 6, M plus 4 and M plus 6 peaks in the mass spectrum of a molecule containing 3 chlorine atoms will be 27 is to 27 is to 9 is to 1. Now we will discuss shortcut method to find chloro pattern in mass spectrometry. We can find the chloro pattern by the formula A plus B power n, where A is the relative abundance of lighter isotope and B is the relative abundance of heavier isotope. Let's discuss case 1 in which there is one chlorine atom in a molecule. So in this case n is equal to 1, and we know that in the case of chlorine the relative abundance of lighter isotope, that is Cl35, is 3, and that of heavier isotope, that is Cl37, is 1. So A is equal to 3 and B is equal to 1. Now putting these values in the formula, A plus B power n will be 3 plus 1 power 1, or 3 plus 1. This is the relative abundance of M, and this is the relative abundance of M plus 2. So the relative intensity of M and M plus 2 peaks will be 3 is to 1. Case 2, in which there are 2 chlorine atoms in a molecule. In this case, n is equal to 2, A is equal to 3 and B is equal to 1. Since n is equal to 2, so the formula will be A plus B power 2. Upon expansion, it will become A square plus 2AB plus B square. Putting the values of A and B will give 3 square plus 2 into 3 into 1 plus 1 square, or 9 plus 6 plus 1. These are relative abundance of M, M plus 2 and M plus 4 peaks. Thus the intensity ratio of M, M plus 2 and M plus 4 peaks will be 9 is to 6 is to 1. Case 3, in which the molecule has 3 chlorine atoms. Here n is equal to 3, A is equal to 3 and B is equal to 1. Putting the value of n in the formula, A plus B power n will give A plus B power 3. Upon expansion, it will become A power 3 plus 3A square B plus 3AB square plus B power 3. Putting the values of A and B will give 3 power 3 plus 3 into 3 square into 1 plus 3 into 3 into 1 square plus 1 power 3, which will be equal to 27 plus 27 plus 9 plus 1. These are the relative abundance of M M plus 2, M plus 4 and M plus 6 peaks. Thus, the intensity ratio of M, M plus 2, M plus 4 and M plus 6 peaks will be 27:27:9:1. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.